Hello and thanks for joining. In this video we'll discuss ERStudio's support for MongoDB. Starting in ERStudio XE6, ERStudio Data Architect provides support for MongoDB, which will allow you to reverse engineer and model with this platform. To begin reverse engineering your MongoDB, go to File, New, and select Reverse Engineering. Choose Login. Once within the Reverse Engineering wizard, choose the native and direct connection. Then in the drop-down menu for database platform type, choose MongoDB. Enter your host name or IP address in the data source field, and then add your database credentials. Select Next. On page 2, you'll choose the database that you'd like to reverse engineer, and whether you'd like to include user collections and/or system collections. On page 3, we can be even more specific as to which collections we want to pull into our model. In this case, we'll bring all 3 collections that are in the library database into our model. On page 4, some of the options are grayed out because they're specific to relational databases, but you still have the ability to infer domains and select a layout option. Choosing Finish will begin the process of reverse engineering your MongoDB database. Now that reverse engineering is complete, we have both a logical and physical model. As you would expect, the logical model is database independent. So the real interest for this video lies in the physical model, which of course is specific to MongoDB. You may be asking yourself, how does a tool that's typically used to model a relational database begin to model a non-relational platform such as MongoDB? Well, because MongoDB has embedded objects, and objects can reference one another, by using a slightly different modeling notation, Data Architect can visually model a MongoDB database. Let's take a look at what I mean. Some of the notation that you see on screen will look familiar to you, specifically the i.e. crow's foot notation. We'll talk about that in a moment, but what's unique to a MongoDB database is the containment relationships that we use here, and a good example of that is this address object. Notice that from patron to address you have a relationship line with a diamond on the patron side and a star on the address side. What this tells you is that patron contains an array of objects called address. You know it's an array because the star is on the address side. Now, take a look at Publisher. Publisher has the same diamond on the side of its relationship line, but there's a 1 on the address end of it. This means that Publisher contains only one instance of the object address. The typical crow's feet notation that you see between patron and checkout and publisher and book is used because checkout references the object ID of patron, and book references the publisher ID of publisher. And therefore, we have a relationship between these objects similar to tables in a relational database. Let's take a look at some of the JSON code for this MongoDB database to get a better understanding. First, let's take a look at patron. You can see here in the patron insert statement that within patron we have address, and there's 2 different instances of address data within patron, and therefore we have an array of objects contained in patron, and therefore you have the relationship notation that we discussed earlier. Now let's look at the crow's feet notation. if we look within the book insert statement here, you can see that within checkout, there's an object embedded within book called checkout, which references the object ID of patron. It also, within book, references the publisher ID of the publisher object. And there you have it. That's how ERStudio Data Architect can reverse engineer and model MongoDB.